I'm proudly and passionately Welsh. I'm an honorary member of the University of Wales in Cardiff rugby club, as well as one of my professorships being in Loughborough, which is a great sporting university. I'm also an honorary member of the Welsh Rugby Union. So being at or invited to a place called the Rugby Tavern was just absolutely irresistible. I think my PA said to Gavin, Neil will talk about absolutely anything for an invite to the Rugby Tavern. So I'm going to talk a little bit about confidence. It's a really digital world, and we're moving into an age where we rely completely on the digital infrastructure. It's a digital infrastructure that provides us not just information, but decision making. It's taking over our lives. It's ubiquitous. We need confidence in it. The ability to measure time to 10 to the minus 18 of a second. Yeah, kind of boring, isn't it? We'd set up the Office of Security and Counter-Terrorism. I was the Deputy Director when we set up, and we were interviewing for a head of science. And we'd asked somebody to come and talk to us about a technical innovation that would revolutionise national security. And this one chap came in and he said, the ability to measure time to 10 to the minus 18 of a second. I had a young man from MI5 on my left and a young lady from MI6 on my right, and we were looking at counter-terrorism. And we thought, what's that all about? Who cares? You know, I've got to watch. A second's good enough for me. And he said to me, sir, I noticed that your secretary is partially sighted. If you could measure time to 10 to the minus 18 of a second, you may have the ability to give her ways to navigate around her desk with centimetre or even millimetre precision. At which point we sat up and we started to think and we started to care. If you fly 2 clocks over the Atlantic at different heights, one along the surface of the ocean and one high up in the sky, as Einstein has said, any of you who are physicists may know, they will register a different time. Why? Because time interacts with gravity. If time interacts with gravity, you can use time as a determiner of gravity. Therefore, you can map gravity. And what does gravity depend on? It depends on the mass of materials. That depends on their relative density. And if you can layer that, you can do some really cool things. Like, did you know the cost that the economy loses every year for roadworks in London is £1.2 billion? £1.2 billion, because many of you probably live in London. We do not have an accurate map of where are the gas pipes, where are the telephone cables. So people dig up holes in the road and they realise they've missed and they've gone in the wrong place and they have to fill it in and dig it up again. If you can map gravity very accurately, you can sense where those cables are. Anybody read the papers around Milton Keynes and sinkholes? Does that ring a bell for anybody? Did any of you lose a car? So a sinkhole opened up in Milton Keynes, a weak spot under the road where water intrusion had eroded the soil under the road, and then the road collapsed and in went the car. If you can measure gravity very accurately, you can spot those weaknesses. It took us 2 weeks, literally 2 weeks, to map a 4 square blocks area in Milton Keynes with traditional gravity sensing. If you can do it accurately at 10 to the minus, actually we're looking at 10 to the minus 16 there of a second, you can find those voids to a depth of 10 metres within an afternoon. So the ability to measure time really accurately is important. Well, what's that got to do with data? What's that got to do with AI? Gavin said about the role of the National Physical Laboratory. I'm not going to plug us. But the UK, indeed the international scientific community, has a very strong focus for many years around measuring things. Because when you measure things, you know how things work. And that goes through industrial processes, it goes through telecommunications, it goes through almost everything that we do in our lives. Measuring is really important. That's confidence. That's what we mean by confidence. We can measure things accurately enough, we can provide standards, we can provide an infrastructure that gives confidence in decision making. We've only got 7 primary units. I won't name them all. Gavin's talked about the kilogram. The one that everybody forgets is the candela, but the amp, the meter, all of those are physical constructs. We've redefined the definition of each of those based on the laws of physics. The kilogram used to be a lump of metal. It's now based on the interaction and the force generated, and it's due to physical constants. The second used to be a pendulum. It's now the radio frequency or microwave ticking of a cesium atom. So it's very reproducible. It's the laws of physics. And what does that give us? It gives us confidence. That's really important in our everyday lives. But, you know, I looked at this when I first started to think about data back in the time I was in national security, but now in my time at the National Physical Laboratory, and started to think about confidence for Generation Z. I'm looking around, I can see some. For those of you who are my age, it's not a third generation punk rock group. Generation Z is those born after 1995 who have never lived in a world that does not have a ubiquitous digital backbone. Yeah, 20 billion interconnected devices, if you believe certain sources, by 2020. I love numbers. 2.5 times 10 to the 18. What's that? 2.5 times 10 to the 18. So 10 to the 9 is a billion. So 10 to the 18 is a billion billion. 2.5 times 10 to the 18 is the sum of human knowledge expressed in bytes from the dawn of time until 1987. It's also the amount of data generated on average every day in 2013. That's the explosion of knowledge. 85% of our digital knowledge or digital data is generated within the last 1 to 2 years. So that's the world in which Generation Z have grown up in and which we have had to get used to. That's just the way life is, and it isn't going to change. The significant difference for me is that dawn of time until 1987 it's Shakespeare, it's Chaucer, it's Darwin, it's Einstein. It's all adding to the sum of human endeavour and human knowledge. In 2013, it's my shopping bill, or my wife's shopping bill, more properly, in Tesco's. Yeah, it's an indulgence of data which overwhelms us. Nice simple fact, I picked this up when I was in defence. In the D-Day landings, every single unit commander had a photograph on, and I'm afraid to say it was on his desk, of the beachhead where they would be going. Every single one had a photograph. When we launched the second Persian Gulf invasion, we could not do that. It wasn't that we didn't have the photographs, it's that we had too many. And we couldn't sort through them in time because of that absolute deluge of data that we could not process, we could not work our way through. So I started thinking to myself about confidence and starting to talk to colleagues in industry, in academia, across government, about what does confidence mean. I can measure a metre, you can all measure a metre, you can all weigh a kilogram, and we can do it very accurately. How does one measure confidence? When we're in a world in which decisions are being made, often on our behalf without human intervention, and we need to understand the confidence in those decisions. I'll unpack it, but let me give you just a couple of examples of where I think this might matter. 3, from the low end to the middle range to the high end. There is a company, and you'll work out who it is, who have built a warehouse. It's 4 times the size of Wembley Stadium. It has 1 human operator. He or she has 2 buttons, green for go and red for stop. Everything else is automated. So every one of the forklift trucks driving around the factory have sensors on the front that scan the barcodes. They're connecting back to a database that says this is the customer order, and they're delivering and packaging ready for transmittal. Does confidence really matter? It's a Cardo, in case you hadn't guessed. Does confidence matter? Well, my wife might throw a bit of a grumble if we got, I don't know if Waitrose actually do economy brand coleslaw, but if we got cheap coleslaw instead of the best coleslaw and we got the wrong order, we might worry a little bit, but it's not a big deal. So confidence doesn't matter that much if it goes wrong in that digital environment. My wife wears a Fitbit. Other brands are available. I don't know if any of you have one. Having started working at the National Physical Laboratory, I live in the middle of nowhere on the edge of Salisbury Plain. So I bought her a Fitbit for Christmas. Well, Father Christmas brought her a Fitbit for Christmas. Every day for a week and a half, we walked the same walk, which we never do, but we did for a week and a half with our dogs, 4.5 miles around Salisbury Plain. And the measurement inaccuracy in the, let's call it a wearable health and well-being device, was phenomenal. Did it matter? No. Were we concerned about the confidence in that data? No. Karen just said to me, I'm a bit low on steps, I'll go around the block again. Or I'm a bit high on steps, I can have a gin and tonic. The confidence didn't matter. But let's just project forward 5 years or 10 years. And think about that wearable device. When you have a blood glucose monitor embedded in that device, if you're worrying about heart condition or diabetes, yeah, and suddenly you're in a world where you have 5G technology. We all know about 5G, I might come back to that. We have 5G technology. Those sensors collecting information are connecting that information to your doctor's surgery. And it's being brought together with your personal healthcare records, and it's prescribing your personalised healthcare plan. Suddenly, your interest in confidence increases, mid-range. I'm looking to see who drives a Mercedes. Any hands? No hands. Gavin, you must drive a Mercedes. I thought you did. I looked you up online. Mercedes have invested a very large amount of money in their automatic braking system. Yeah. How does that work? A set of sensors, and you may notice the repetition of some words, a set of sensors on the front, the sides and the back of the vehicle that are collecting information. They're connecting that information together to go to the vehicle management system. And that vehicle management system is making decisions based on the information that's flowing through to it. Actually, your need for confidence is at a very, very different level. Very different level. Because when somebody steps out in front of you and the vehicle says collision, avoidance, brake, but it also says, by the way, there's a 10-ton lorry on your rear end and your baby's on the back seat of the car, then your need for confidence in that decision-making cycle goes right to the extreme. It is literally a matter of life and death. So sometimes confidence doesn't matter, coleslaw from a delivery organisation. Sometimes it's quite important, personalised healthcare. And sometimes it's absolutely, absolutely critical. So we've been focused very much, I'm Welsh, as I said at the beginning. I like to alliterate. We focused on circle with a centre, and the centre is confidence. In this new developing digital world, what does confidence mean? How do we measure it? How do we understand it? How do we improve it? Not to the highest level, but to the level it needs to be at. Yeah, and that might vary depending on the need or on the application. So we drew a circle, because I think when we talk about AI and machine learning, and I was talking to a colleague here earlier today, this has been a discussion that's been ongoing in various circles for a number of years. And there are many, many different views. But generally, people talk about the data. It's about the bits and the bytes, isn't it? It's about the software. It's all about the algorithms and the analytics. I can attest to you that it isn't. So what we're proposing, we're leading some of this thinking across the UK, is that we think about confidence in the data at the centre of 3 interlocking circles in a Venn diagram, if I may, and I alliterate them. So where does that data come from? Somewhere it has to be collected. Yeah, that might be typing in at a keyboard. It might be a sensor on the front of the car or the forklift truck. It might be your Fitbit. But somewhere in there is a sensor which is collecting data. So if you need to understand your confidence, you need to understand the reliability of that sensor. I mentioned earlier 20 billion interconnected devices, your fridge that orders its own milk in the future. You know, a slight diversion, but people talk about 5G and assume that 5G is the next one of these. Yeah. So 5G is all about the next mobile phone, and it's all about wireless. 5G is, future communications isn't. So if you think about 5G, 5G is when you, Gavin, get in your Mercedes and you're halfway on the road home, and then you lend it to me. You're going to lend it to me, right? And I'm driving it to my house, and I realise I'm running out Gavin's fuel. The car says you're low on fuel. The nearest petrol station is here, because I've connected to it, maybe through Google Maps or other routes. I've connected to it, I've scanned all of the petrol stations, and I know where the nearest one is. By the way, Wales are playing France this evening. It won't be the day we play England, because I wouldn't borrow Gavin's car that day. Wales are playing France that evening, so you will want extra orange juice to entertain your guests. So the cheapest deal on orange juice is at this petrol station. And by the way, I'll drive you there. Now that is all about a connection of those sensors and of the information. So in that digital world, we're collecting information through sensors, through sensor networks. We're connecting all of that information. But there's no point whatsoever in collecting the information and joining it all together, connecting it, if we don't understand it, comprehend. If we cannot understand, make sense of that data. And if we can do those three, understand our ability to collect information, the way in which that information is connected together, and the way in which we comprehend it. Only by doing those three in a virtuous circle can we lead to the confidence. So our whole approach is based around that sort of triangle of understanding the collection, understanding the connection, understanding the comprehension, which is what's going to give us that confidence in data as we move forward. Let's bring it down to AI. Because it's nice and straightforward if you're in a warehouse. It's actually quite straightforward if you're Rolls-Royce. It seems really, really complicated. Rolls-Royce is not a production company anymore. Rolls-Royce is a data company. And they don't sell engines. They sell an engine service. And the whole backbone of their USP is that they understand intimately at every stage of the engine's life cycle how it's performing. How do they do that? They collect information at every point, from the manufacture through the in-flight to the refurbishment. They connect that information together and they comprehend what that means for servicing. And that gives them confidence in their engine data. So all the way through that life cycle, if you like, that triangle is giving us that confidence. But we want to do better. Arguably, the Rolls-Royce example is very, very simple. We measure very accurately the temperature at which the components are produced, the ampage that is used in the equipment that's putting that equipment together, the mole, the volume of material that is used in each of the mixes, being used in ceramics or metamaterials or nanomaterials. Lots and lots of measurement, but it's a nice, linear, straightforward path. We put it on an aeroplane and we measure the performance. We measure the flight time. It's all straightforward, and the analytics, therefore, are linear. If we want to do better, then the future is moving us towards machine learning. My background, defence and security, we started this many years ago, looking at things like neural networks. That may be familiar to many of you, but we're now morphing into the language of artificial intelligence and machine learning. What does that mean? If you're looking at confidence, think back to my collect information, connect information, comprehend information to gain your confidence in the data. What does that mean when you introduce into the equation artificial intelligence and machine learning. Suddenly you move from a sort of linear and well understood pathway to a much more complicated, much more complex, and I'll differentiate those two words should you wish to in Q&A, but a much more complex scenario, a much more complex situation. So AI, machine learning, is going to give us fundamental difficulties. So what are we doing? What are we doing? What are we doing both nationally and internationally? There's a lot of activity. I've talked about my 3 circles in the Venn diagram: collecting, connecting, comprehending information to give us confidence. For me, that's about systems engineering. It's about understanding the holistic approach to the system, understanding the problem through a systems engineering perspective, and building a system level response to the problem. It's not about the bits and the bytes. It's also about the sensor. It's also about the connections and the interface. If one's looking at Rolls-Royce and factory of the future, it's about understanding the interactions of millimetre wave connections across that factory, the interferences within those. I'm sure many of you studied or looked at, read the media about drones over Gatwick. Yeah, 36 hours shutdown. Yeah. Should be straightforward. We do it in Syria all the time. What's the difference? Syria is a big open desert, and if you want to use RF energy or EM, electromagnetic interference, to bring down a drone over a desert, it's an empty airspace and there's nobody on the ground with a baby buggy. If you want to do it over Gatwick, it's a very complex RF environment. So understanding and having confidence in your data in an environment like that, and having confidence in your system where you are collecting the information of where are the other RF emitters, you are understanding the connection, the interaction of all of those emitters, so that you're not taking down the control tower or an incoming aeroplane. Understanding that environment is becoming more and more complicated, and AI and machine learning are adding to that complexity. So what are we doing? We're looking really hard at the 3 aspects of that, working on the assumption that if we can crack the 3 corners, collecting information, understanding our sensors, connecting information, understanding the interaction and interference in that communication network, and understanding the comprehension, the analytics in that ubiquitous digital backbone, that will lead us to an understood confidence. So there's lots of things that we're doing which I can talk about at some length if you wish to go into the technical detail. Things like uncertainty propagation. So these things don't stand in isolation. How do uncertainties move through the system if you have a systems level approach to this? If we're looking at, let's stick with Gatwick, if we're looking at taking down a drone with an RF or EM radio frequency or electromagnetic interference, understanding the uncertainties of our understanding of the wave band that's going to affect the drone, understanding the uncertainties of the RF environment that we're operating in. Who's got their mobile phone out? Probably me. Which is giving you not a static infrastructure, but a very mobile, agile infrastructure that you need to be operating within. Uncertainties propagating throughout it. One of the most important things for me, and this is kind of easy if I go back to my 7 SI units, they're all quite easy to apply standards to. We can have a standard for the meter, can't we? It's nice and straightforward. It's going to be this long. It's 3'3" in my language. And a standard for the amp and the candela and the mole and the kilogram and the second. It's straightforward. Standards in the digital and data world are very different. Who set the who's old enough to remember Betamax versus VHS? You don't have to admit to it. Don't admit to it. I'll pretend it's only me. Who set the standards for those 2 systems, and how did we come to one above the other? And the answer is industry set the standards, and the consumer decided which would win. We are very good at identifying lessons. One of the things we identified when we looked at 1G, you're too young to remember 1G, but first generation through to fourth generation mobile phones is that we did not set any standards. They were all driven by industry, and we had to retrofit, we had to retro-engineer. Yeah. So everything was then working back from, oh, we've got all this stuff, but you know, in the early generation, I couldn't take my mobile phone to France. Yeah. Let's look at 5G. Can I take my car to France? And I'm not going to say anything about yesterday's vote or today's vote, but you know, whether or not that will change. Can I take my car to a different country and it will still drive? It will still interact with the smart infrastructure in New York City or in Taiwan. So if we don't have those standards, then we're always going to be playing catch up. So for me, in this, is it a Wild West, or maybe, given today's environment, a Wild East of development? Industry is driving the bow wave, I guess, and it isn't driven by people like me, even in my previous defence role. Here's a number. You may love this. 1963. I wasn't working for MOD then, although it felt like it. The then government chief scientific advisor wrote a paper that said in the UK the MOD invests 6 times as much as the rest of the UK government put together in R&D. It's a slightly biased figure because the layout was slightly different. But it was true that in those days, the Cold War and the space race drove technology development. You know, you look around you, the internet. Who invented the internet? Where did it first come from? Where was the origins? Sat-nav, young lady on her phone there, probably plotting her way home. Where did sat-nav and GPS come from? Where did all the way up to the iPhone 4S come from? They were all funded through either space research or defence research. And now it's totally the other way around. Google have literally turned around recently and said to the US Department of Defence, you're not important enough to us for us to invest or to take collaborative programs with you in data and artificial intelligence. 3 numbers. You'll notice my theme of 3, that's because I'm Welsh. Number 1, total UK investment, the biggest single investment that we've made in a single technology ever, really, has been in quantum technologies. Tune is, over the last 5 years, is around about $500 million US, depends on the exchange rate, which keeps changing, $500 million US. The US Department of Defence alone, so that's the whole of the UK investment, US Department of Defence investment for all things quantum technologies is $500 million. Same as the whole of the UK put together. Google's investment just in quantum computation, yeah, you guessed it, $500 million. Yeah. So Google are investing as much in one of arguably 6 different fields of application of quantum technology, as much as the whole of the US DoD and as much as the whole of the UK put together. So industry is driving the consumer market, the need, the application, what people are doing, what's going down in Groovetown, really. And therefore, we're not in the world that we were in 1G, where we had the opportunity, which we didn't take, to regulate, too strong a word, normalise, too soft a word, put some standards in place, maybe the right middle ground, to give us that solid foundation that we were, if you like, future prepared. One of my team has said to me there won't be anything beyond 5G, and he's tech savvy. Japan are already looking at 7G. Some of them tell me they're looking at 8G. I don't even know what that means. But my response to my team was, well, after 1G, we said there wouldn't be anything beyond 1G. There was. And at each stage, we've been surprised by where things have gone. So a lot of the work that we're doing is trying to look at and work very closely with the commercial environment. The UK has a very strong desire for us to be at the forefront of a number of things. And if one reads the industrial strategy, who's seen Back to the Future? DeLorean, yeah? Yeah, remember the DeLorean with the wing cars? That was, until this came along, I bet you've seen it too. I love it, my kids love it. That was the last time that the UK had an interventionist industrial strategy. What's that, 20 years ago, 25, 30 years ago? I don't know, I wasn't even born, I'll pretend. It was a long time ago. We now have an interventionist industrial strategy, and more importantly, it's backed up with hard cash. Question in my mind is, how do we use it, and where do we use it most effectively? If you read that industrial strategy, like it or loathe it, you're all welcome to your views. Writ large, all the way through it is the digital world. It's the data environment. It's the fact that future comms, future digital infrastructure will be even more ubiquitous, and we will rely on it more than we ever realised. My final story. I took out a ship in the Channel with a $100 off-the-shelf GPS jammer. It was a controlled experiment, it was okay. What we didn't know was we took out 32 separate systems on that ship that all relied on GPS for their timing integration. So the encryption systems, the identify friend and foe, the communication systems, all used a GPS timing stamp. I was talking to someone earlier about finance. MiFID II is the boring regulation that says you have to have an accurate timestamp on all of your trades. And that makes sense. The New York Stock Exchange moved their stock exchange left of London because that meant that the New York information got to them slightly quicker. So they could make decisions literally microseconds quicker than the city. They wouldn't let me do it. I took out the ship in the Channel. They wouldn't let me do it. We calculated we could take out the square mile for $1,700. We modelled it. We didn't do it for real. The scary thing is that when I spoke with the chair of the New York Stock Exchange, he didn't know his reliance on GNSS GPS. I asked him, or he was asked, I wasn't allowed to do it myself because I'm a Brit, what's your reliance on GPS? He said, traffic's a bitch, excuse my New York, I don't do the accent, my folk could be late for work. He didn't realise that every single stock and share transaction was timed by GPS. Yeah? How much of our daily lives are reliant on decisions that we're not making? So for me, that's the challenge, is understanding the confidence in those decisions as they're made, whether we make them or they're made on our behalf, whether they're made in an Ocado factory or whether they're made by your top-end Mercedes. You're going to get your top-end Mercedes, Kevin, on your behalf. That really, really matters. And we can only do that by understanding not just the digital, the collection of information, the connection of information, the comprehension of information, leading to our confidence in those decisions. And AI, machine learning, is going to make that landscape even more complex, even more difficult. It's going to make us have to keep running to catch up. And I think we, whether we're in government, industry, or even academia, are going to have to work collectively if we're going to keep the UK at the forefront of it. I'm going to stop there, but thank you very much for your attention.